In this video, I'm going to explain how to do the cooling charts in the tube safety charts, as well as how to calculate heat units. So the first thing let's look at is the tube rating chart, and this is where we discussed in the presentation you have to determine if an exposure was safe or if it was unsafe. And really all this is just plotting on an XY axis graph and determining if your technical factors fall above this MA curve or below it. So let's look at the first one, 100 kV, 0.2 seconds, and 150 MA. Here's the cooling, or the tube safety chart. 100 kV, so we're going to start here, 0.2 seconds. 0.2 seconds is this line, so we're going to follow this up till 100 and 0.2 meet, right where my cursor is. The MA curve that is asking is 150 MA. Remember, if it falls below the curve, it is safe. If it falls above the curve, it is unsafe. So in this case, your answer should be safe. Let's look at one more of these. Number 2, 120 kV, 1 second, and 200 MA. We found 120 kV. You should have found the 1 second line right here. Move all the way up to 120. And the MA curve is 200 MA. So, 200 MA is down here. So your answer should be unsafe. Next, let's take a look at heat units. Number 8. How many heat units are generated by an exposure of 80 kVp, 200 MA, and 0.5 seconds on a high frequency rectified unit? The constant for high frequency is 1.4. The constant for one phase is just 1. On number 8, you're going to start with 80. And we're going to times 200 times 0.5 times 1.4. When you multiply that all together, you should get 11,200 heat units. And you just write HU for the unit. You can still multiply it in kV and MA, unlike the power rating we did in the previous chapter. So don't get those two confused and don't get the constants confused. Let's look at one more. Number 9, how many heat units are generated by 10 exposures of 70 kVp, 300 MA, and 0.25 seconds on a one-phase rectified unit? We're going to multiply 10, you have to include that, times 70 times 300 times 0.25, and it's just times 1 because we're coming out of one phase. Multiply all that together and you get 52,500 heat units. Let's look at a couple cooling chart problems. Number 10, if 50,000 heat units are produced during an exposure, how long will it take the anode to cool completely? So let's find 50,000, and 50,000 falls right here at 6, about 6 minutes. And it wants to know how long will it take the anode to cool completely. Well, this curve goes all the way down and stops at 15. It actually doesn't go all the way to 16, it stops right here at 15. So 15 minus 6 should be 9 minutes. So it would take 9 minutes from a 50,000 exposure to cool completely. Let's work one more. Number 12, if 50,000 heat units are produced during an exposure, how long will it take the anode to cool down to 25,000 heat units? We know that 50,000 is about at 6. And now we're moving to 25,000, which is going to be right here. That's 9 minutes. So 9 minus 6 is 3. So your final answer would be 3 minutes.